In this video, we will talk about the following words with their definitions and the properties of the stochastic processes. So the first one is Whiteson's stationary process. If we call one process is a Whiteson's stationary process, it means the estimation of the xt, which is the process, is a constant number, or sometimes we mostly denoted as eta, and for their autocorrelations on time t1 and t2, it is equals to the correlation on a certain time difference, which we call it tau, and where tau is the difference of the time 1 and time 2. And mostly when we try to prove if some process is a Whiteson's stationary process, we can only use the just find the estimation and the autocorrelations in this problem. And for second one, the independent increment process, it means for the different times on T1 on time intervals, whereas T1 and T2 and T3 and T4, if the process difference on this time can shows increment, and also these two times are on the non-overlapping intervals. That can means that the intervals are independent, and which can be called the independent increment process. There are three types of the independent increment process: Poisson process, random walk, and the Wiener process are following these properties. The third one, for the Markov process, we have the Markov chain definition for Markov chain, which is for the time for the probability xn equals to xn given by the other times intersections, it is equals to p the probability on xn equals to xn and x1 n minus 1 equals to minus 1, and also times xn minus 1 equals to xn minus 1 given by xn minus 2 equals to xn minus 2, and time all this together and finally ended by the x0 equals to x0. And so if we see the Markov chain, we can imply to the Markov process definition, which is the if the some past times like the x on t0, it doesn't really affect for the previous one like t1, and also not for t2. So some past time it doesn't affect cannot has no influence on the futures when the process when the present time is known. For the fourth one, for the normal processes, which is called the Gaussian processes, it means that we have the xt on different times are jointly normal, and the distribution is mostly like the Gaussian distribution. Which given by the time at xn, we can have the equation like this one, where the C is the where the C is the autocovariance matrix and the eta is the expected matrix. And that for the eta is also a function. Generally, the eta is a function that is followed by t. And the fifth one, strict sense stationary process. That means if we given a process on certain discrete time, then if we move them by given a different given by a difference of the time, like move all the process to the left or to the right with eta unit, the process still looks same, and that one can be considered as strict sense process. This process is basically really hard to meet, and if we really would want to find some property of it, prove some problems for it, we have to prove this equation is proved. For the sixth one, the white noises, it means that if we have that is for talk about our winner process, and suppose we denote the winner process as Wt, and find the derivative of this winner process on the time t. We can receive a relation of on the t, which is called Vt, and the Vt is kind of the Gaussian white noise. And on this part, we have the expected value for Vt is equals to the derivative on the estimate on Wt, which is the winner process, and derivative it on time t, and finally this the noise estimation is 0, and autocorrelation on time t1 and t2 is equal to some constant alpha times the difference on the impulse function on Tn between T1 and T2. And the seventh one, the mean ergodic process. If its limit when t get closer to infinite, and follows that the ingression from negative t to t, and its process follows integral on xt from negative t to t and times 1/2t. And that one, if we can find an answer that is same as its expected estimate in the mean square sense, then its mean square sense is same. So, and we call this is mean ergodic process. We don't talk about it on other senses, for example, in probability or in probability 1. Just talk it on MSS. And the eighth one, martingale. The martingale is called it's a sequence of random variables for which the condition expectations of the next value is equal to the present value, and we denote it as the expected value for the process given by some time equals to x1 is equals to this time itself when we have s. Time s is less than equals to t. So for the previous one,